CCNA version 7, switching, routing, and wireless essentials. Topology. The names of the devices may vary. Addressing table. Names may vary. Names of hosts may vary. Configure switch security. You will configure switch SWA. The name may vary, but is this switch? This. Switch ports Ethernet 1 to 5 are the active switch ports from 1 to 5. Gigabit 01 is a dedicated link to router R1A. All other ports should be secured. Gigabit 01 is the connection to router R1A. Names of devices may vary, but is this connection? Configure VLANs. Okay, here on this switch, SWA, use a console port from PC, access the console. Terminal, okay, enter, enable, configure terminal. VLAN 10, name users, VLAN 999, and user. VLAN 10, name users, VLAN 999, name unused. Exit. Configure active switch ports. Remember, active switch ports from 1 to 5. And also Gigabit 01. Configure the ports from 1 to 5 and Gigabit 01 as static access ports in VLAN 10. Interface range from 1 to 5, and Gigabit 01. Switch port mode access VLAN 10. Activate port security on the ports. Port security should be applied on ports from 1 to 5 because they are connected to end devices. Interface range only from 1 to 5. Configure the ports to accept a maximum of 4 MAC addresses. First, enable port security, and then maximum 4. If a violation occurs, configure the port to drop frames from the unauthorized MAC address, log it, and send an alert. So that means is restrict. Violation, restrict. MAC addresses should be present in the MAC address table for a maximum of 10 minutes before they are removed. This is the aging time. Switch port security, aging time, 10 minutes. ports should add the learned MAC addresses to the running configuration. MAC address sticky. MAC address sticky. Configure the MAC address of HQ11 as static address on port fast Ethernet 1. Port fast Ethernet 1 connected to HQ11. Close the terminal, open command prompt on HQ11, here HQ11, and verify the MAC address. ipconfig /all. Copy this MAC address, physical address, and on terminal, okay, switch port, MAC address, and then paste, enter. Okay, it's duplicated because it was learned for the sticky method, but anyway, enter this command. Or apply this command before to apply MAC address sticky. Protect against DHCP snooping. Activate DHCP snooping globally. Exit on global configuration mode. Use the following command: IP DHCP snooping. Activate DHCP snooping for two VLANs configured for 10 and 999. VLAN 10, 999. Configure the ports to limit the rate of 5 DHCP packets per second. Okay, only on the range from 1 to 5, because they are connected to end devices. One to 5. IP DHCP snooping limit rate 5 packets per second. Configure the port that links to the router as trusted. The port is gigabit 01. Interface gigabit 01. IP DHCP snooping trust. Enter. Okay, snooping. Very good. Ward against ARP attacks by implementing DAI, dynamic ARP inspection. Activate DAI globally, exit. Then activate DAI on two VLANs. These two requirements can be made in only one command: IP ARP inspection VLAN 10 and 999. Configure the port that links to the router as trusted. Gigabit 01 IP ARP inspection trust. Exit. Configure spanning tree protocol STP by configuring port fast and BPDU1. This should be made on ports connected to end devices from 1 to 5. Spanning tree port fast. Okay, don't worry about these messages. This is the command. Very good. And spanning tree BPDU guard enable. Very good. Mitigate STP attacks by configuring BPDU guard and port fast on the active ports. Okay, very good. From 1 to 5. Verify and show running config. Very good. And gigabit 01. Very nice. Secure unused switch ports. Move all unused switch ports to Vlan 999. Configure all unused switch ports as static access ports. Okay, from 1 to 5 are in use and gigabit 01 in use. Configure terminal interface range from 6 to 24 and gigabit 02. Static access port, switch port mode access, Vlan 999, Vlan 999, shutdown. Very good. Configure addressing and DHCP. You will configure the DHCP and interface addressing on RB10. This router, the name may vary, but is this router. Okay, configure the DHCP interface addressing on RB10 to prepare for implementing the Wireless Lan controller network. Okay, for DHCP for this network. Okay, first configure an address and subinterface for the Wireless Lan user network. Configure subinterface 10 on the router interface that is connected to switch SWD. This switch SWD, the name may vary, but is this. It's connected to RB10. The router should provide router and stick routing to VLAN 10. Configure the subinterface with the address from the addressing table. RB10. Configure subinterface 10. Is this. From a PC access to this router. Go to this PC and desktop terminal. Okay, enter, enable configure terminal. Interface gigabit 000010. At the description, this is the network running to 168.10 belongs to users, so you can use a description, any description, the Wireless Lan users, and set the encapsulation .1q. The instruction says VLAN 10. Enter. The addressing 192.168.10.1. Subnet mask. And that is enough. Configure the DHCP pool for Wireless Lan user network. Exclude the router interface address in the wireless LAN 10 address of the wireless LAN controller. Okay, first exclude the router interface address, exit IP DHCP excluded address 192.168.10.1. This is the router on that network, on users network, wireless users network 10.0. Exclude the, and also exclude the wireless LAN 10 address of wireless LAN controller, of this controller. So wireless LAN controller has two interfaces, management and wireless LAN 10. So exclude 10.254. Very good. Name the pool wireless LAN -hosts. IP DHCP pool case sensitive wireless LAN hosts. Enter network 192.168.10.0.24. Default router 192.168.10.1. And don't forget the DNS server for IPv4. Okay, the pool to use this address network 10.0, very good. The pool should also provide the default gateway is this, and DNS server. The DNS server on IPv4 is this 192.168.51.100, 163. DNS server 198.51.100, 163. Enter. Exit. Configure an interface as a DHCP client. On RB10 router, on this router RB10, configure the interface that is connected to the edge router. The interface connected to the edge router. This gigabit 001 is connected to edge router to receive its address over DHCP. Okay, gigabit 001 DHCP client on this interface. RB10 gigabit 001. The IPv6 already set, but gigabit 001 DHCP. Interface gigabit 001 IP address DHCP. And you received this IP 10302. Very good. Configure static routes. You will configure static, default, floating, static, and host routes in both IPv4 and IPv6. You will configure R1A is this router, the name may vary, but is this, and RB10 is this, the name may vary, but is this. Company has decided that it wants to use static routing between all its networks. Company wants to use the Ethernet links between routers for mods data traffic and reverse serial link between R1A and RB10 for backup purposes in case of the Ethernet links become unavailable. You will be configuring floating, static, and default routes. Okay, for example, R1A is using gigabit connections, but this connection is a redundant link in case of the failure of this gigabit link. Configure static routes on R1A. This router IPv4 default route to the cloud using the Ethernet link as the preferred link and the serial link as the backup. Okay. This is the cloud. Okay, this is the cloud internet, and configure a preferred link to use gigabit interface and backup link to use serial interface. Administrative distance 10 for the backup route. These routes should be directly connected. Okay, directly connected means to use the local interface to create the routes. Okay, R1A from a PC, connect to the console. Terminal, okay. Enable configure terminal. IP route, the default route and IPv4, and directly connected says directly connected use the local interface. This is to reach the cloud. This is the cloud. Gigabit 02. Okay, don't worry about this message. And create the backup using serial 010. Serial 010 and 10. Administrative distance of 10 for the backup route. Enter. Very nice. IPv6 default routes to the cloud. Ethernet links is the primary route and serial link is backup. Administrative distance of 10 for backup. And route should specify the NetHub interface address. So to create the routes on IPv6, use the NetHub address gigabit 00 IP on edge router and serial 010 address on RV10 router. IPv6 route, the default route on IPv6. And I want to know what is the 00 on edge router on IPv6. A2 64. A column 2, no prefix, enter, and the backup using serial 010 on RV10. B2. B2 for backup administrative distance of 10. Configure IPv4 static routes to Village Branch LAN Wireless Lan user network. Okay, here. Village Branch LAN Wireless LAN user network is 192.168.10.0.24. 192.168.10.0.24 is 0, and following the same guidelines as above for the type of root and administrative distance. Okay, for IPv4, use the local interface. Okay, gigabit 002. Gigabit 002. And the backup using serial local interface serial 10. Okay, this interface. Serial 010. Administrative distance of 10. Configure IPv4 and IPv6 host routes on R1A to the server OS 10. This is the server OS 10. And the town office LAN. And this LAN, town office LAN. The name of the networks may vary, but is this LAN. And the name of the server may vary, but is this server. Create a directly connected route for IPv4 and NetHub route for IPv6. Okay, IP route. The IP address of the host server or STAN 3122 says the host, not the network. 192.168.3.122. And when you create a route for a host, the subnet mask is 32. This 255, 255, 255, 255. Because it's for the host, not for the network. For IPv4 is the local interface serial 011. Serial 011. And now for IPv6 route. This is the address of the host 3122. Column 122. And it's not the network, so the prefix is 128. And do not use the local interface for IPv6, use the NetHub IP address. So I want to know what is the IP address of serial 1011 on RO10. Serial 11 on RO10, this D2. Column 2. Enter. Configure static routes to RB10. This router. The name may vary, but is this router. Go to this PC, enter. Enable configure terminal. RB10 must also be configured with the static routes to the other 3 networks in the company network. It will require floating, static, and default routes in IPv4 and IPv6 following the same guidelines as were used for the R1A static routes. Okay. IPv6 routes use NetHub address. IPv4 use the exit interface, local interface. All routes should prefer the Ethernet links over serial link. Okay, if you are here on RB10, the preferred link is this gigabit 001, and the backup link is this CL010. Backup floating static routes use the administrative distance of 10. Configure IPv4 default routes to the cloud using the Ethernet link as the preferred link and serial link as the backup. This is the cloud, so configure RB10. IP route, the default route. For IPv4, use the local interface. Gigabit is preferred, gigabit 001. And don't worry about this message. Backup serial 010. Administrative distance of 10 because it's the backup. Configure IPv6 default routes to the clouds. This is the cloud again. Ethernet links, primary route, serial links, backup, administrative distance 10, next hop IP address. Okay, the IPv6 route, default route on IPv6. I want to know gigabit 001 on edge router on IPv6. Edge router, the name may vary, but is this router? And I want to know gigabit 001 on IPv6. C1. Okay, no prefix. C::1. Enter. And the backup using the IP address, IPv6 address of serial 10 on R1A. Serial 010 B1. B1 is the backup, administrative distance of 10. Very good. Configure a wireless LAN using a wireless LAN controller. In this part of the assessment, you will configure the wireless LAN controller to provide wireless access to the network. Username and password are the default admin. Okay, first access from admin PC to wireless LAN controller on management interface. Wireless LAN controller management interface 192.168.100.254. Close the terminal, web browser. Use HTTPS //192.168.100.254. Enter. Login. Use username admin, password admin. Login. And now configure a Vlan interface. Create a new interface, Wireless Lan 10. Go to controller, interfaces. You have the management interface and virtual interface. Add a new here, new. The name is Wireless Lan 10. Case sensitive, space 10. For Vlan 10. Apply. Very good. Be careful here because you are connected to physical port gigabit 1. Verify is assigned to port number 1. Okay. Interface name, Wireless Lan 10, port number 1, this port 1, and Vlan 10, very good. And use information in the addressing table to configure the addressing settings for the interface. Okay, verify the addressing table. Wireless LAN controller, wireless LAN 10, 192.168.10.254, subnet mask 24. One eighty two dot 192.168.10.254, subnet mask 24, and the default gateway is 10.1. The interface will be using the Dhcp pool that will be assigned addresses on the network configured on the subinterface assigned to VLAN 10 on router RB10. On this router, you created a previous step pool for the wireless LAN users. And this is the subinterface you created on RB10. The name of the router may vary, but this subinterface, and this will be the DHCP server 10.1. Primary DHCP server. Use the router 192.168.10.1. Very good. Okay, up here, apply. Okay. Configure radio server. Configure the wireless LAN controller with the radio server IPv4 address. Okay, go to security. Here, a new entry. The IP address here of the radio server. Addressing table 172.16.1.124. 172.16.1.100. Okay, very good. And the shared secret is provided here. RAT secret case sensitive. Be careful. RAT secret. Confirm RAT secret. Then apply. Very good. The radio server. Configure a wireless LAN. Create a new wireless LAN. Name it Wireless LAN 10. Okay, go to wireless LANs here. Create new, go. Type a wireless LAN, profile name, this name, wireless LAN space 10. Wireless LAN space 10. SSID SSID-10. SSID-10. This ID is only an identifier. It's not necessary to belongs to 10. You can use any number, but for good practice, select 10. Then apply. Very good. Don't forget to enable this wireless LAN. Enable. Don't forget that. Okay, apply. And also don't forget to choose the interface. by default is the management selected but use Wireless Lan 10. The interface previously created. Very important. Apply. Okay. Now configure Wireless Lan to use WPA security policy. Okay, go to security. On layer 2, select here WPA and WPA2 and enable the WPA2 policy, not WPA policy. Version 2, WPA2 policy enable. Encryption AES and use the .1x authentication key management. Use this .1x authentication key management. Enable this because it's enterprise, not PSK, not pre-shared key. AO2.1x. Configure the wireless LAN to use the radio server that was previously configured to authenticate wireless users. Okay, this should be configured on AAA servers. And here, select the server previously configured, port 1812, this IP address. Open Advanced tab. Scroll down. Flex Connect sections activate Flex Connect local switching and Flex Connect local authentication. Flex Connect section enable Flex Connect local switching and Flex Connect local authentication. Apply. Okay. Configure the Dhcp scope for the management network. Configure a new Dhcp scope to be used by the lightweight access points. This is the lightweight access point. And other management devices on the network. Go to controller, internal DHCP server, DHCP scope. By default, there is a pool, but create a new and use the name wired_admin case sensitive. Wired_admin. Apply. Very good. Here is, and click here. Start the scope address on 100.240 and end the scope address on 100.249. 192.168.100.240 and 192.168.100.249. And the network of 100 is 192.168.100.0, subnet mask 24. Default routes 192.168.101 and DNS server. Okay. Verify on addressing table. This is the management network. I'm configuring a DHCP server on the Wireless Lan controller on this network 100.024 for devices like lightweight access points, not for the users, for devices. Okay. The DNS use this IPv4 address 198.51.100.163. Okay, and other information required can be found in the addressing table. Very good. DNS, default routes, subnet mask, network, and start and end addresses. Enable, apply. Very good. Okay, verify here on the lightweight access point if received the IPv4 address. Wait a moment. Now it has IPv4 192.168.100.240, the first IP in the pool. Okay, very good. Continue. Configure an SNMP server. Configure SNMP server to receive drops from the Wireless Lan controller. Okay, from Wireless Lan controller, receive drops on the radio server that is also SNMP server. Management. SNMP trap receivers. The trap receiver should be the server and new. Community name, branch wireless case sensitive, branch wireless, and the IP address of the server, the radio server that is also SNMP server. Okay, enable no IPsec, apply. Very good. Configure the wireless host. Configure LT1 laptop. This is the client, LT1 laptop. Okay, access the laptop, desktop, PC wireless. Go to profiles. New profile, and the name WorkNet case sensitive. Workspace net. Okay. Look at here the available network SSID 10 configured on the Wireless Lan controller. But go to advanced setup. Infrastructure mode, the SSID 10, next. Network settings automatically Dhcp, next. Enterprise authentication. Enterprise is this WPA2, no WPA, WPA2 enterprise, next. Username, user1, password, user1 pass case sensitive, capital P, user1 pass, next. Save, connect to network, and wait a moment, and you should see the connection here between lightweight access point and laptop. Very good, you are connected. Now verify, go to laptop, close this application, command prompt, ipconfig, your configuration using the HCP. This being internet, the web server 203.0.1.13.25. Okay, repeat. Success. Use the name CCNA version 7.pd. CCNA version 7.pd. Enter. Wait a moment. Success. May take a while. For example, ping to this server. OS 10. OS 10 is 3.122, this server. Okay, repeat. Success. And also from HQ11, this PC, the name may vary, but it's this PC. You can close terminal, command prompt, ping the server, this server 192.168.3.122. Success. Ping web server. Success. Repeat. All success. Ping the name. Okay, may take a while, but it should be success. Success. Also, you can use IPv6 to ping the web server. Success. Ping OS 10 server using IPv6 3.122. Success. HQ21, this PC. The name may vary. Ping internet. Success. Repeat. Ping IPv6 on web server on internet IPv6 address. Success. Ping this server OS 10 3.122. Success on IPv6. Also on IPv4 3.122. Success. Navigate to web server Success. Very good. Thank you very much.